let me go to Mark Sokol now and get some lab updates, if Mark is with us.
Yep.
There we go.
There we go. Yep, here we are, Tim. Okay, so I'm actually out in the lab room over here. We're working on these gyroscopes. Just wanted to show you for one in a second. So check that out. This allows us to put the servo motors in from both ends, and we'll have that torquing motion going back and forth. And this should produce about 1 to 2 pounds of thrust. While making one of them, we decided why not just make 3. So we actually have 3 of these units over here right next to me. There's another project that we have going on inside the Faraday cage. That was that experiment that you guys saw last time with the 2 parallel plates, the antenna. That is actually hooked up inside the Faraday cage at the moment. Turn on the laser. We were running it the other night too, try to see if there was any effects. And I have also the laser interferometer table set up around it so that the laser runs through it. I'll first show you the setup with the lights on. You can see over there those 2 copper plates are the bottom one is the active element, so that's going to be hit with RF coming through from that coax cable, and the top one is the ground plane. There's a capacitor in the center that allows for a high voltage potential between them, and the idea being we're trying to get a standing wave in that in-between section. So there's a laser light that is bouncing back and forth inside that inside the Faraday cage over here on this table. The mirrors make the light bounce through the where we expect to have see some sort of effect 3 times, and then it comes out, bounces off the bathroom over there where there's a little mirror, and then that hits the wall over here. This allows us to see if there was any change when the antenna is set up. You can see a little better with the lights off. We've had an issue with the RF amplifier that's at the resonant frequency of this engine is not running properly. It's going straight into reset. So I do have a lower frequency unit that we powered up that does run right now. So we're just playing around with that one in the meantime while we get a replacement for that RF amplifier. So that's pretty much everything that's going on here at the lab. We have a couple people coming in for the month of December. Aiden Schaefer's about to fly in again. And Ilya Lamin, he's coming in from Montreal. And I know also Charlie Crawford has a couple things going on. He was doing a replication of the Alexei Chekarkov device and actually received lots of components from Alexei. So we're able to get some more information from him about what's going on with that.
Yep, thanks, Mark. You want me to show it now?
Yeah, go for it.
Go for it.
Okay, great. Let me swap the video. There it is. All right, so second package, yep, arrived this week. And this is the ultrasound circuit. And I'm currently, writing down the electronics, updating his schematic for it, and working on a build of materials. I'll share this on American Anti-Gravity's Facebook and on our 24/7 APEC WhatsApp. That's a quick schematics to work on that. And the other circuit that came in was the high voltage. He's showing here it's at 20,000 volts and just an on-off switch. and it's powered by this adapter power. And it has the standard like European outlet. I got an adapter for that. And I think there's more to this circuit that will be arriving with the third and final package, which has the Graviflyer frame. But currently the output just has these 2 wires, which are soldered and look like they crimp onto the diode capacitor array, which I'm still not sure how that works. The first package was the gravitometer, as he's calling it, and the Tesla coil or a catcher. And I've already taken those apart and built those. So I've built a few other models of the Tesla coil there. And aside 3 of them, I was trying John Hutchison's effect of having 3 Tesla coils together and see if there's any interference bands with a radio receiving those signals. And you can kind of hear the electromagnetic fields interacting with that. And I have that on my YouTube channel at Charlie C. YouTube. And that's about it. There's some interesting designs here with this transformer. He wound another wire around a toroid inductor to make this transformer for the piezoelectric. If anyone's wondering, it's a real small piezoelectric speaker, same that used in like birthday cards. And it's really good for high frequency, like ultrasound that he's using. But they're all pretty simple circuits. Once you can see on the side, this one is the flyback transformer he has here, and you get this from like an old CRT, or he said a computer monitor, I guess. And these are some high 5-watt resistors. This is a transistor with a huge heat sink. This whole black part is a heat sink. And that's about it. The rest is, yeah, so I haven't turned on these 2 yet, but they're similar to his workmanship with this other design. So just want to make sure all the electronics, everything look right before turning them on and testing them, but hopefully that'll be this week. And when the last package comes next week, I'll be able to put everything together and start testing them. So I'll look forward to that. And yeah, that's it for now.
Awesome. Well, so, and then let me see. So Mark is texting. Mark, did you have anything more, or should we go to Jeremiah Pop?
Go to Jeremiah Pop. Yeah, you can move on to Jeremiah. We've pretty showed you guys everything that is new here at the lab.
You know, that CNC machine, it looks like you've got more there too. It's bigger. Sorry, there's an echo. That's why I'm pausing. Sorry, there's an echo. That's why I'm pausing. Let me see. I'll ask Jeremiah if he has anything to share.
Actually, I'm right smack in the middle of assembling a engine right now. It's gonna run on a very, very simple principle. I guess I'll speak a bit about it. It's gonna operate on a principle similar to how lifters work, but instead this entire engine is going to be completely enclosed. What it will demonstrate is the electrogravitic component that exists in ionic propulsion systems that's capable of being utilized under the correct conditions. So that will be something up and coming. I'm working on assembling that right now. I was hoping to have it ready in time, but oh well. So.
Oh, okay.
Other than that, yes, I have a lot going on, but that was the main thing right now, and that's going to be the project I'm going to finish before I move on to anything else.
No sneak preview then. No sneak preview today.
No, unfortunately not on that one.
Okay, we'll have to wait. Well, would you guys like to go to open discussion then? Well, why don't we do that? We'll put it on open discussion. So that, yeah, the way open discussion works is you guys unmute yourselves to talk, and whatever comes up, whatever comes to mind. And yeah, nobody needs to raise their hand or anything like that. So
hey, Tim, I have something to share.
Yeah. Oh, Todd. Okay.
Hey guys, how's it going? I ran a test today of my gravita-cooler, which is basically a graviflyer in a box, and I 3 times in a row I saw 8 grams of weight loss.
Do you have video that you can share or anything like that?
I do. I do.
Okay, well, let's go to Todd and then we'll do open discussion.
All right. And 1 second while I try to share this.
Yeah, and thank you for letting me know. Sorry. It's kind of quiet today. I think it's because we're so close to the holidays, you know?
Okay. You see the screen over here?
Yeah, it looks great. I can see you. I see the screen. Sound is great.
And make sure the sound is going to come through from the video. How do I do that? I remember there was a thing with this.
So when you share, and you may need to have a plugin installed, and I'm not sure if you do or
No,
not.
I've done it before.
Yeah, so when you start the screen share, it'll say share audio. So you may have to stop sharing and start sharing again.
Try it again.
Yeah, and on the screen share button where it has you choose the screen to share, right? It should have a little check mark on the bottom left, and that'll say,
Yeah, share sound. Got it.
there you go, sir.
Okay. Okay, I've moved it up to where the results were. It took me a while to get it to actually stabilize. And to be honest, I couldn't reproduce it after I did this. I went back after lunch and I could not do it again. But I think it has something to do with the tuning of the motors. So I got a couple more power supplies coming tomorrow so that I can control each motor separately. As you can see here, I've got both motors connected together to one power supply. And then this is my high voltage power supply, which is powered by this old piece of junk over here, which keeps shutting off on me. So I was having some issues. And like Alex did confirm that Alexi is right. When this thing runs, my phone switched off twice while I was recording. So there we go. Are you hearing anything? Because I'm not hearing anything. Oh.
It sounds like it's about to take off, I'll be honest.
That's because the two motors aren't at the same RPM, so you're hearing a beat frequency. But you can see over here, I'm at -8 grams.
Wow.
It actually went, it wobbled, when it wobbles.
It showed something. See if we can repeat it. Well, doesn't like the off balance, I'll tell you that.
Right.
We're at 0.34. -1, -7, -5, -4. -6, 7, -8. Hey, that looks interesting. That's twice in a row. You got some negative numbers on it while it was running. The next step is I have another box with 2 more little power supplies in it that I can control each motor separately, and then I could, with a tweaker, be able to dial in them in so you don't hear that beat frequency, so that we can tune it so that the 2 motors are running at the same RPM. Right now you can hear when it's running that slow oscillation. That's the beat frequency because the 2 motors are not turning at the same RPM. Alright, it went back to 0. Let's try it again.
I have to hold it down because it'll walk across the table.
Yeah, that's 4 grams. -5.
I'd call that a minor success. Let's see what happens when I can tune the motors. Have a great day. Oh, don't forget to like and subscribe and hit the notification bell to know when I've uploaded new videos.
Yeah, you know, I should follow up on that. So that's the Warp Drive Tech channel on YouTube. And we've got links to that, I think, on, well, all over our site, but also on the APEC channel on YouTube. So yeah, everybody, please subscribe to Warp Drive Tech. And so you're going to tune those motors then, right? You're going to.
Yeah, I got the little power supplies that I had are little circuit boards, and they're supposed to be, 5 amp boards, but they don't have enough energy storage capacitance to spin the motors when the high voltage is applied. They wouldn't turn it. So I ordered 2 30 volt 10 amp power supplies that'll be here tomorrow, probably not till 9 p.m. or something. But so when I get those, I'll have one for each motor, and then I can adjust that. And then I will use this, the power supply that I was using for the motors to run my high voltage, because the old junky power supply keeps shutting down on me, which I did a video after lunch. I came back, I tried to do it again, and I could not reproduce these results. And I checked everything to make sure the voltage was getting to the discs, but still, I did see about 0.5 gram to 1 gram, but not 8 grams. And so I got the 2 power supplies coming tomorrow, and then I should be able to tune the motors to whatever maximum weight loss I can get. And I did notice in the other video that the beat frequency, as it's oscillating, the weight was changing in sync with the oscillation. So obviously there's something there to tuning the two together that should help.
And when you were saying it walks across the table, that was the beat frequency that made it walk, right?
It's the vibration. When Mark made the discs for me months ago in the summer, they were for a number 6 screw. And when I got the big 1 1/4 inch magnets on it, they needed a 1032 screw, and then the big shaft, because the old shaft was wobbling too much. So I got big plastic shafts to insulate the disc from the motor, and those needed a 1032. Actually, it's an M8 now. It's an M8 screw, and so when I drilled out the holes for the disc for the bigger magnets and bigger screws, the drill press walked and this aluminum stretched and whatever, and it's not centered anymore. And so it's way off balance. You can actually see one of the magnets isn't on the same circle as the others, the other 5. So it makes it vibrate like crazy. And Mark, when he is done playing with his gyros, needs to make me a new disc so that I can get this thing to balance and stop walking all over the place. I have to hold the scale down. At first, if you watch the earlier parts of this video, it's about 20 minutes long. It actually fell off the scale, so I taped it down to the top of the scale. Then the whole scale starts walking across the table. So I need to fix that. I need to get rid of all those vibrations so that it it's smooth. And I had it smooth when I had the small magnets on there and everything was aligned. But now with the big magnets, after drilling it out, it's no longer aligned and it walks all over the place. So, but it did. I mean, 3 times in a row there, we saw 8 grams of weight loss. It could be simply the vibration in the scale. I can't confirm it because I can't reproduce it yet. But hopefully tomorrow I can get those power supplies and tune them, and maybe in a week or 2 I'll have a new disc to play with, and we can see it again.
That'd be exciting. That'd be exciting.
So yeah, so that does at least confirm a couple things. It shows some weight loss, and it isn't levitating like the Graviflyer. I only had 20 kilovolts, not 30. My power supply will go bang when I get up to about 26. So I was running it at 20 because I didn't want another heart attack. And it seems to be, promising. And like I say, in the next video I did, the camera shut down about halfway through the first video, and then I had to redo it, and then it shut down after 3 minutes, and then I had to redo it again. And but I got a little weight loss, but I didn't see 8 grams again. So obviously you can actually hear it's not the same. So the tuning was different. And so when I get the 2 power supplies, I'll be able to tune it to whatever it needs to be. That's all.
Well, thank you, sir. Thank you.
Yep.
Okay. Wait, there's Jeremiah. Jeremiah.
Yeah, in the meantime, do me a favor, take some magnet, some regular north-south magnet that you have sitting around, and tape it to the side of the motor so that you can control the field slightly. You'll be able to vary the RPM that way. And you might be able to control the beat frequency more precisely than you think. Once the motors have warmed up, the bearing friction has fairly well stabilized. And yeah, it still vibrates like crazy. And I'd recommend trying to actually re-drill that hole and mount that magnet back down. Maybe use a little super glue.
Can't. The hole's too big. I can't do nothing with it.
Well, you can super glue the magnet in place and shorten it up. But it's possible. Either way, yeah. Mark needs to get on it. That's a call to action, Mark, to get him those new discs, because obviously he's already getting some results that are promising enough to investigate, and all he needs is a stable, balanced, drilled disc with the right size holes.
Thanks, Mark. Appreciate it. Thanks, Jeremiah. The problem is right now I can't really hold a magnet. I got to hold the thing down.
Could you mute yourself, Mark?
Oh yeah, Mark, that's your.
The echo is really bad.
Yeah, I have to hold the thing down when it's vibrating, so I don't really have a hand free to hold the magnet. But tomorrow, hopefully, I'll be able to get those power supplies, and then I'll have double control. I had this power supply at 5 amps shut down on me twice too. So when you apply the high voltage, it puts quite a bit of drag on the motor, more so than just the magnets alone.
Interesting.
So,
see, that's already a really good sign.
Yeah.
And just observing that effect means that your energy is going somewhere.
Yeah.
And
no, I expected it to.
So let me just ask,
motor.
so everybody's clear, and so I'm clear again. The layered assembly, you have 2 motors with discs inside of a box. So what is the assembly from the bottom to the top inside that video? What motor has what disc, and what's that disc made of, and what order are they layered in?
Okay, so inside the bottom of the cooler, attached to one of these gray boxes, is a motor, and then inside I got a shaft that's about 3 inches long. It's plastic so that it's insulated from the motor. The disc is insulated from the motor. And then I have a 150 millimeter disc made of aluminum and a thin layer of mu metal, high mu 80, sandwiched on top of that. And then I have 6 1¼ inch N42 magnets, hexagonal around that.
And they're on the top side of that mu metal disc then.
Yeah, the magnets are on top of the mu metal and bolted through the disc. And then the disc has then that box is completely sealed so that you can't touch the high voltage. And I have a 30 kilovolt wire, insulated wire coming out that is then attached to the power supply. And then is identical setup, same, but upside down, sitting on top is the one you see the motor in the gray box, and then the 3-inch shaft, and then the aluminum disc has no magnets on it. It's just the aluminum disc. Now the disc on the bottom with the magnets is negatively charged, and the disc on the top with no magnets is positively charged. All the magnets are north facing up.
And just to clarify, the top disc, that's just an aluminum disc. You don't have a mu metal layer on that?
No,
is that correct?
no, that's correct.
Okay, so pure,
So
okay, awesome.
It's just like the other half of the capacitor to maximize the charge on the bottom disc. That's the one that's really.
It's just out of the curiosity whether or not there's a ferrous effect on the top disc or not. That was the main curiosity. So no.
Yeah, no. And then, like I said, the bottom disc is negative. The top disc is positive. What was that, Mark?
What kind of material do you want the discs made out of? I have this
Steel.
perforated. Oh, you want it steel?
Yeah. You said you had some steel.
Oh yeah, we do have steel actually here. Let me see here. We got some nice steel discs over here.
Yeah, nice and stiff and magnetic.
Yeah, so no aluminum, just steel, right?
Yeah. And it's just one. I don't need two. I just need the one. I
Oh,
sent you the file.
You know, I should say, William, just jump in. You don't have to raise your hand, sir.
Oh,
Yeah, I think we're in open session now. So
I'm
Yeah,
letting
that's
that
fine.
conversation close out. I was having a conversation on your YouTube channel with someone about whether or not the center plate was of any value to this design.
I don't have one yet. When I put a plate in there and look at the magnetic field with I did a video earlier today with some of this green magnetic viewing film, and I've done videos in the past using iron filings and also using like spinning piece of aluminum to
Right.
little pieces of scrap that would get trapped in the magnetic field. And as soon as I put any kind of metal layer, steel or aluminum on there, those effects pretty much go away. So putting a middle layer in there, the magnetic field really doesn't get through it to the top disc. Whereas this one, without it, the magnets will physically drag the upper disc around. So if I don't apply a motor to the top disc, it'll spin that motor backwards because they are counter rotating. The one on the bottom is rotating clockwise and the one on the top is rotating counterclockwise because they're upside down. But if I don't apply power to the top motor, the magnets will drag it around in the same direction. And but as soon as I put any kind of layer in between it or separate them further, that doesn't happen. So I get the greatest coupling without anything.
I guess that was my question. My remark on your YouTube channel was that you're trying to create two toroidal fields. Is that how you perceive what you're trying to create? Or
That's one. It's one. It acts more like two when you put the layer in there because it insulates them from each other. But when there's nothing in between, then the negative charge going clockwise and the positive charge going counterclockwise forms one toroid of magnetic flux.
So I think the Chekhov machine or Chekhov machine had that center plane in there.
Yeah.
And so I guess I'm asking, why are you diverting in your own solution versus what we've seen in prior videos?
Because nobody knows how it works, and I'm doing it piece by piece to see what has what effect. And this is where I'm at right now. Is I've shown that I get some weight loss without the metal plate, without a Tesla coil, without any ultrasound, just the magnets and the high voltage and the spinning discs. So it's a first step, and as I go further, I will add center plates and Tesla coil and ultrasound until I've nailed down what is really making the effect. And in my opinion, this should have the maximum effect because all those other things are low power. The high voltage on the Tesla coil is practically no power at all, and the ultrasound is practically no power at all. The magnets, on the other hand, are close to a Tesla spinning, and so that is actually a lot of power. And if you're going to defy gravity, you're not going to do it with low power. So I'm looking at where's the maximum amount of power, and that's what I have set up right now. And like I said, without anything in between them, and when I apply the high voltage, you can tell it loads the motor. So I'm working against the pointing vector for the electromagnetic field in that toroid.
Okay. I think Jeremiah remarked previously when you weren't online that we felt the effect was cumulative, or that there was a hysteresis lag, like it builds.
It appeared to be, yeah, it appears to be. But like I say, when I tried to replicate it, I didn't see that again. So it's confusing right now. You know, I did it 3 times in this video to show that, you know, it was repeatable, and then I ate lunch and came back and I couldn't repeat it. So I was kind of disappointed, but you can hear the RPM and the beat frequency was different. So something changed. And I don't know what, but I think tuning the motors is part of the setup that Alexei always says is so difficult, is you've got to get everything tuned properly.
I was going to remark that maybe it's the physical location. Like you charge the location, and then when you try to replicate that, well, you charge that location already. Maybe you
Yeah, I got bleeder resistors on everything. It discharges relatively quickly.
Okay.
So I don't see that. I mean, maybe the mu metal got a little magnetized, but the magnets are going to sit on there anyway, so it's not going to change anything. The aluminum's not going to stay magnetized, but yeah,
Well,
I have a lot of open questions right now, and I got a lot of work to do. So
If I may add to that, just consider that you have 2 discs and 2 motors, and they're identical, William, and you rotate them at the exact same RPM, but in these 2 discs made of the same conductor, one of them has excess electrons and the other one has a lack of electrons. Well, the lack of electrons are going to be protons, and every single electron that's in excess inside of the lower disk is going to be trying to couple to one of those protons inside of the upper disk. Now, stationary condition, this is nice and balanced because the protons and the electrons can draw these nice kind of lines of direct closest point connection where they can easily couple. But when you try to rotate these 2 disks at the same RPM, something interesting happens. See, the protons, they can't move. So the electrons that are left over inside of the top disk, which are far fewer than the ones in the bottom disk, they're going to try to rotate around the top disk, but there's not enough of them. So they are going to try to push through, and there's more resistance. Therefore, there's a power loss. They end up scattering all the electromagnetic energy. The bottom disk, on the other hand, has electrons, free electrons that can move in excess on the surface of the disk. And so they freely compensate and move, allowing the bottom disk not to have to feel the same force of drag as the top disk does. This differential ends up building, if you can imagine, if I have 1 proton here on the edge of the disk and, 1 proton here and 1 electron here on this side of the disk, and I try to, if I try to, rotate these 2 points apart from each other, imagine that there's like this twisting force that's happening between them. If one of those fields is twisting faster than the other, you're going to end up with a differential, and the force will try to balance out by the physical polarization between the 2 shifting in one of the 2 directions. That shift has an effect on all the masses of the charged particles, and since the electromagnetic force is so strong, that actual shift in the polarization of space between them has a significantly stronger effect than one might expect. That's what we would call retrogravity, if you will. So that's interesting to note. Just imagine the way that the torsion field is sort of linked to itself and how you can twist these things up and get that differential in total electron drift velocity and therefore the radiated electric field caused by the motion of all those charged particles. Because it does matter relativistically, the speed of the particles.
Yeah.
So could you increase the weight by doing that, just like you can decrease the weight?
Yeah, absolutely, you can.
I did see an interesting effect too when I went back out, was that and this may be my digital scale acting up because of the high voltage, but I noticed that I get about 0.5 gram of weight gain just turning on the high voltage. No spinning, nothing, just turn on the high 20 kilovolts and the scale reads about 0.5 gram higher.
So that's your static counterberry
Probably.
in the literature, right? It's the static charge.
Yeah, probably. It's probably just due to the high voltage. Like I said, it shut my phone off twice while I was recording. So it's definitely radiating some energy.
Sure. Yeah, I guess I'm trying to make a parallel between the magnetic field of a photon and this device. And what I've seen is a double toroid structure that allows it to travel freely through space. And so maybe I'm wrong in thinking that this device works like a photon magnetic field, but if it were, you'd be shooting for a double toroid.
Well, if you go back and watch my the last APEC presentation I did, I think it was in September, I explained my model of how I think this works. So yeah, I use classical electromagnetism. I don't have to get into photons. I've got billions and billions of photons here. So thinking of it like a photon is kind of thinking small. I'm looking for big power, something that can lift the UAP. So.
Okay, fair enough.
Right. Okay. Thanks, guys. And open discussion.
Hey,
There we
Tim?
go. Yeah, and I think, yeah. Hey, Robert. And I think Harold
Hi.
tried to
I'd like
jump
to
in
see
there,
the
but his,
propulsion.
I have a question for you when it's time.
yeah, go for it. For me or
Yeah, I guess it could be you. There was gentleman and Paul Lavalette. Is he the same guy who wrote this book?
yes, one and the same. He may still be here.
Oh, I wanted to say hello to him.
Oh no, it looks like he's gone for the evening.
Looks like he left, yeah.
Yeah, and you know, and
Quite.
you mentioned in chat that I didn't mean to cut him off. I was trying to juggle time slots.
It's
so
all right.
I promised Franc Milburn. I said, Frank, please come to the conference, and so I got myself a little turned around with the scheduling, but I managed to
All right.
squeeze everybody in. So
No problem. Thanks.
Yeah, I thought Paul's commentary on the Nazca drive was awesome with the Hugh fella.
yeah, and then what he said about pulsars was interesting also. I'm not familiar with that, but Dr. Ansbro was. So I guess Paul's a doctor too. I should probably use that title
Yeah.
consistently. Yeah, it's interesting. So what I mentioned before the conference was we should probably, I mean, we're pulling into Christmas time pretty quick. So we should probably take a break until January, and that'll let Mark and Jeremiah and Todd and everybody catch up with their projects too, because I think that we're kind of pushing ahead of what they're able to produce. So although Mark's lab keeps getting bigger, I swear to God that machine didn't look that big last time I saw it.
Yeah,
Ted, thank you again for
this machine
hosting
is massive. Yeah, this is actually one of the last parts we just built. Just came off the CNC machine for our third gyroscope device. So yep, this entire project was something I was working on the past week and a half with the CNC machine. The machine was running almost constantly, churning out parts, and there's a lot of bad parts too. Well, we were dialing in the G code, but we should be able to get to Todd's disk either later tonight or sometime tomorrow and get those parts churned out. Yeah, it's really exciting. I'm hoping to see a working gravity flyer sometime soon.
Well, good luck, Mark. If I don't see you guys before Christmas, have a Merry Christmas. I'm gonna head out.
Oh, Sam, why don't you come down to the lab again?
If my girlfriend will let me, I will.
Oh,
I'll text you, man. I'll let you know. Hopefully sometime soon.
yeah, we're gonna have a couple interesting people down here as well.
Yeah, I
Yeah.
want to come back by soon.
Well, Mark, what are some of the other, you're working on several projects, right, Mark? You're
Yeah,
almost-
quite a few projects. We got the warp drive thing. We got Alzaphon. We've been having trouble with the Klystrons. They're, either they're gassed out or just plain out broken. So I'm in talks with CPI about getting some new units, and everything's kind of slow because of the holidays. Takes them weeks to get back to me, and so hopefully we'll get that done as soon as possible. I'm also hoping to get a replication of the X-band using the working traveling wave tube amplifier setup they have at only 20 watts. So last time I ran it, there was a problem with all the heat all the energy turning into heat inside of the coax. So I got this better, more flexible coax, and I cut myself a 2-foot piece out of it just to hook everything up, and hopefully less heat will enter the cable and more of it will make it into the experiment. And even if we get 10 watts, let's say we got 50% attenuation, there should be some effect at that point as well. I know Wayne was seeing positive results with an Alzafon-like replication, and he was, you know, less than 1 watt. So I would expect, if we do this correctly, to see some significant effects.
Yeah.
So that's something that we're excited about as well. I mean, it's all coming to head. I think that this major push for anti-gravity that we did with starting APEC has actually already come to fruition. We're seeing the seeds of it already. It's going to happen this time. This time it's for real.
Well, I mean, I would say that this is a transformative year, right? I mean, I like go back to what was it, August? Who would have thought that the government would admit UFOs are real? That's the last thing that I was expecting in this lifetime. Who would think that 6 months later they'd be opening an office to investigate them, you know?
I wonder if anyone from that office is going to be like a regular attendee at APEC. I mean, if they're honest about it, I mean, that's kind of what
We already are.
they probably already are. Michael Boyd, do you have a second job now?
Yeah, there you go.
Well, I have this problem with my lawsuits against the government.
Oh, that's right. Yeah, you're unhireable at this point.
At least for a government job for the media. So are we in open session now?
Yeah, we are.
Yeah, go for it. Go for
Okay,
it.
because there's something I wanted to share. Let me take my hand down. Here we go. So now I'm going to play this video, and I'm asking you to listen carefully for the sound. You're going to
Wait, is this related to our topic?
Well, we're talking. It's talking about space-time metric engineering.
Oh, okay.
Okay, that's what this is what this video is showing. But there's this interesting sound that I heard.
Are you stuck here? Move the camera. It's really low. Oh my God.
Did you hear that sound?
Mm-mm.
Let me do it again.
Are you sure that's not, added to the video?
Yeah.
I mean, did you look down, or did you pursue the original source of this video footage just to verify it?
Yeah, I did, and it seems valid. So you listen it again, please.
Are you stuck here? Move the camera. It's really low. Oh my God.
Okay, so you heard that sound?
Kind of like a
Was like a slurpy sound.
a slurpy sound.
I guess is the best way to describe it. So now I wanted to show you that.
Oh, and here, I thought you were talking about the low frequency hum.
No, listen, let's do it again. Got to get the time right. Oh, sorry, guys. Come on. Here.
Are you stuck here? Move the camera. It's really low. Oh my God. Oh my. Are you in the voice room?
Did you hear that? Let's do it again. Hold on, sorry.
So what is it? What is it that you?
Are you in the voice room?
It's a little difficult to make out.
Are you stuck here? Move the camera. It's really low.
Here it goes.
Oh my God. Oh my. Are you?
Did you hear that noise?
That one?
Yeah, it sounds kind of like plastic wrap.
Oh, geez. Okay. Thank you for better describing that. Okay. Now that you've adequately described what you're talking about in a way that my brain can understand, my simple monkey mind, now I will try to turn up the sound and listen very closely to said audio.
You gentlemen have both completely lost me, but that's okay.
Up here.
Okay, I'm gonna tell you the truth, Michael.
Okay, did you hear
so-
that plastic
yeah,
wrap sound?
It just barely comes through. Here's the thing that I hate to tell you, video compression automatically through Zoom will remove the high fidelity, high frequency subtleties that you are specifically wanting us to hear.
Oh, yeah,
But-
I get
but
it. Okay.
But you could hear it, correct?
I
Just
thought-
barely. It sounded like compressed harmonic tones. It got totally crunched down.
Yeah, the
I-
MP3 is
I-
going to cut the top and bottom.
But the only reason I know what it was supposed to sound like is because I've spent too many years as an audio engineer, and that we would have to actually look at the link individually to hear the sound adequately, or you'd have to send it as a tiny little file, drop it in chat or something like that. But either way, yeah. So go ahead and explain the point of what you wanted to make note of on this staticky crunchy bag sound.
Sorry, I'm trying to get out of the chair. Okay, there I go. So what I was trying to explain though is that orb, the orb that you see, the streaking orb, that's making the sound. And I saw, and there's some other parts of the video where you see the orb, and whenever the orb shows up, you hear that little sound of the.
Oh man, now I know where you're going. Damn. Okay, that's a very valid point. I never even thought of that. Interesting.
So
Interesting.
So I'm just, I know I'm pushing the edge here, Tim, but there's definitely something that's doing with space-time metric engineering, and that's why I'm curious about these effects.
Ironically, hate to say it, but if Bob Grenier was in a different time zone, he would have a few things to say about that video there too. And so would Ken Shoulders, I imagine. So very valid point for those who are familiar with the work of those folks in Hutchinson. Yeah, very valid point. I would have to agree. It's quite curious, and we've seen that kind of phenomena before. It matches the track marks left on metal. So.
Okay, thank you, Jeremiah, and thanks for letting me share that.
Yeah, it's a quiet night tonight. Well, guys, I think that was everything I had. Should we call it a night, do you think, or?
Tim, when do you plan on doing the next APEC after Christmas?
Well, I'm not sure. Maybe the beginning of January. How does the beginning of January sound? That gives you guys time to catch up and wait. That
Sounds better than the beginning of February. Let me see. So that would be January 1st. That would be New Year's. January 1st is a Saturday, and then January 8th is the next Saturday.
Oh, well, it's up to you. How hungover will you be on New Year's Day? You'll be very hungover.
Me and Jeremiah last New Year's, we were both at the lab trying to, get in a couple last experiments.
Okay, well, that's yeah.
We even wrote.
We extended the trip just to make sure that we had to know. We had to know, and we will have to know again. Coming up very soon. So what I would actually like to do is, instead of killing it, okay, so I have a full Zoom account now, so I can host unlimited sessions. If you want to toss host this way, I can take that over, and then what I want to do is kill recording and kill the live stream even on the channel. Sorry, folks, tuning into Alien Scientists, so that we can just kind of have a off the books, not recorded, open discussion.
Oh, you mean this
Anybody
evening?
wants to- Yeah, just if anybody wants to, it might offer new opportunities to say stuff.
Well,
off
let's do that then. Yeah. So let's call it a night. And again, everyone, this has been APEC for December 11th. And yeah, so I will shut down recording now and
Thank you, everyone.
see you guys in January.